Hi students, in this class we will learn about the representation of graphs in motion. In mechanics we learn about motion and how do you represent this motion graphically. That is what we are going to discuss. In this session we will discuss about distance time graphs, displacement time graphs, velocity time graphs, acceleration time graphs, and a quick recap of what we have learned. Before proceeding to the graphs, let us recall what we learned in the video for kinematics equations. In that video, we discussed about speed, velocity, and acceleration. What is speed? Speed is the rate of distance. What is velocity? It is the rate of displacement. And what is acceleration? It is the rate of change of velocity. Distance unit is meters. Time, the unit is second. Therefore, speed is having the unit meter per second. Similarly, displacement is having the unit meters and time seconds. Velocity is also having the same unit meter per second. What about acceleration? Change in velocity. Velocity unit is meter per second. Therefore, change in velocity is also having the velocity unit meter per second. Meter per second divided by second. Therefore, the acceleration unit will be always meter per second squared. Since distance is a scalar quantity, speed is also a scalar quantity. Displacement is a vector quantity, therefore velocity is a vector quantity. If velocity is a vector quantity, acceleration is also a vector quantity. I hope you know the quantity scalar quantity and vector quantity. Scalar quantity means quantities which is having only magnitude and no direction. Vector quantities have both magnitude and direction. First, we will learn about distance time graphs. In distance time graphs, we will plot distance along the y-axis and time along the x-axis. What is a graph? Graph gives a relationship between two variable quantities. Both the quantities are variable. The independent variable is generally plotted along the x-axis and the dependent variable is plotted along the y-axis in a graph. This graph will give you the relationship between these two variables, dependent variable and independent variable. Independent variable is the variable which the experimenter is controlling, whereas the dependent variable is the variable that changes in response to the independent variable. In distance time graph, distance is the dependent variable and time is the independent variable. For a stationary object, the distance time graph is a straight line parallel to the time axis. Say the time axis is divided into 5 seconds. 0, 1, 2, 3, 4, 5. At the first second, the distance covered is this point, and on the distance axis, let this be 1, this be 2, and this be 3. What is the distance covered at this point? It is 2 meters. At this point, that means 2 seconds. What is the distance covered? It is still the same 2 meters. At this point, what is the distance covered? 2 meters. At 4th second, it is again 2 meters. At 5th second, it is again 2 meters. That means the object is at the same distance. The object is not moving. It is stationary. From the graph, it is clear that the object is stationary. Therefore, for a distance time graph, if it is a straight line parallel to the time axis, the object is stationary. From the graph, it is clear that as time increases, the distance is remaining the same. It is stationary object. For uniform motion, the distance time graph is a straight line like this. What do you mean by uniform motion? The motion must be uniform. Equal distances must be covered in equal intervals of time. They are directly proportional to each other. Hence, you will get a straight line for uniform motion. For a non-uniform motion, you will get a curved line instead of a straight line. This curved line indicates that the speed is not uniform. It is a non-uniform motion. Now we know the distance time graphs. The distance time graph for a stationary object, distance time graph for a body moving with uniform speed, and the distance time graph for a body moving with non-uniform speed. Let me take the gradient or slope of the graph. Gradient or slope of a graph is change in y-axis divided by change in the x-axis. This is the y-axis and this is the x-axis. If you take the slope or gradient of this graph, you must take this change. This is the change in the y-axis delta y, and change in the x-axis. This change is indicated by delta x. What is delta y by delta x here? Delta y is the distance, because distance is plotted along the y-axis. Distance divided by, on the x-axis, this x-axis we are plotting the time, therefore distance divided by time, and we know speed is equal to distance divided by time. Therefore if you take the gradient or slope of this distance time graph, you will get speed. Here delta y is equal to 0, therefore the distance delta y is equal to 0 means speed is equal to 0. That is, when the graph is a straight line parallel to the time axis, the slope is equal to 0 or speed is equal to 0. The slope or the gradient gives you the speed in distance time graphs. We understood that the gradient of a distance time graph gives you the speed. Gradient means change in y by change in x. If you look at this graph, the steeper line is this red line, or the slope of this red line is higher than the others. If the slope is higher or if the graph is steeper, the speed will be greater. In this graph, the speed is highest for this red line and the speed is lowest for this blue line, because for this blue line, the slope is less. Please note that as the slope increases, the speed also increases. The steeper the graph, the greater the speed. We learned about the distance time graphs. Now we can learn about the displacement time graphs. This displacement time graphs is similar to the distance time graphs. The only difference is that in the y-axis, earlier we plotted distance. Now we will plot displacement instead of distance. Displacement versus time. The graphs are similar to the distance time graphs. For stationary object, you will get a straight line, and for uniform velocity you will get a straight line like this, and for variable velocity you will get a curved line. The gradient of a distance time graph gives you the speed, which is a scalar quantity, since distance is a scalar quantity. But the gradient of a displacement time graph gives you the velocity. If you take the gradient of this graph, this is delta y and this is delta x. What will be the gradient or the slope of this graph? Displacement divided by time. What is displacement divided by time? That is velocity. Therefore, the gradient of a displacement time graph gives you the velocity, which is a vector quantity. Displacement is the distance moved in a specified direction from the point of reference. This curved line indicates that the gradient is changing and hence the velocity is changing. The gradient of a displacement time graph gives you the velocity. As discussed, the steeper the line, the faster the object is moving. Steeper the line means the gradient will be greater. When you plot a displacement time graph, please note that this displacement is a vector quantity. It is a distance in a given direction. It can have negative values. Here you can see a distance time graph and a displacement time graph. In distance time graph, distance versus time, and for displacement time graph, it is displacement versus time. For distance time graph, the body is moving with a constant speed, and at this point it is stopped, and then it is moving at a higher speed but constant. But when you plot a displacement time graph, you are interested in its direction also. In this graph, at this point, you can see the body is changing its direction. As I told you, it can have negative values also. You will not see any negative values for this distance time graph. Next is velocity time graph. In a velocity time graph, you will plot velocity along the y-axis and time along the x-axis. For a body moving with uniform velocity means the velocity is uniform. That is, velocity is not changing. The velocity remains constant. In that case, the velocity time graph is a straight line parallel to the time axis. This is a straight line parallel to the time axis. Say this velocity be 50 meter per second. At any instant of time, if you look at the velocity value, the velocity remains the same. The velocity is 50 meter per second. The velocity remains the same, uniform velocity. For uniform acceleration, the velocity time graph will be a straight line, because the velocity increases equally with equal intervals of time. If you take the slope of this graph, delta y by delta x, that is delta y divided by delta x is equal to, delta y indicates the change in velocity. Change in velocity divided by time. Change in velocity divided by time. What is change in velocity divided by time? That is equal to acceleration. Therefore, if you take the slope of a velocity time graph, you will get the acceleration of the object at that interval. If the body is not moving with uniform acceleration or uniform retardation, and if the object is moving with variable acceleration, the shape of the graph will be a curve like this. This curve shows that the acceleration is not constant. In velocity time graphs, we will plot velocity along the y-axis and time along the x-axis. In this graph, velocity is constant. Velocity is constant means velocity is not changing. If the velocity is not changing, will there be acceleration? No, because acceleration is the rate of change of velocity. Velocity remains constant, therefore acceleration is equal to 0 and slope is 0 in this case. This graph indicates uniform acceleration. Here the slope is positive and hence the acceleration is also positive. Whereas in this diagram it indicates uniform retardation. Retardation means negative acceleration. In negative acceleration, the slope will be negative and the acceleration is negative. If the acceleration is not constant, the slope is curved. This graph indicates that the acceleration is not constant. Area under a velocity time graph gives you the displacement. Area under a velocity time graph means velocity into time. What is the definition we learned for this velocity? Velocity is equal to displacement divided by time. Therefore, velocity into time is the displacement. If you take only the magnitude of this velocity, then you will get the distance. Finally, we will learn the acceleration time graphs. In acceleration time graphs, we will plot acceleration on the y-axis and time on the x-axis. The curves are similar to the velocity time graphs. If the acceleration is constant, that means the acceleration is not changing, you will get a straight line parallel to the time axis. If the acceleration is increasing uniformly, then the shape of the graph will be like this. If the acceleration is variable, then you must draw a curved line to indicate that it is varying. The area under an acceleration time graph gives you the change in velocity. We know acceleration is equal to change in velocity by time. Area under the graph means this acceleration into time. Acceleration into time is equal to change in velocity. Therefore, area under the acceleration time graphs gives you the change in velocity. Area is equal to change in velocity. Delta V represents the change in velocity. Let us revisit the graphs that we learned today. In distance time graphs, we understood distance is plotted on the y-axis and time along the x-axis. And in velocity time graph, you will plot velocity along the y-axis and time along the x-axis. In this graph, this indicates the constant speed and distance is remaining the same, which indicates it is stopped, the object is stopped, and this increase shows that it is moving with a constant speed but higher speed. In a velocity time graph, this portion indicates constant acceleration and this is constant velocity. That means the velocity is constant, the body is not accelerating, and this indicates decelerating, the body is changing its direction. Here in this graph also, this velocity is plotted along the y-axis and time along the x-axis. Therefore, this is a velocity time graph which shows positive acceleration, negative acceleration, and zero acceleration. In displacement time graph, displacement will be plotted along the y-axis and time along the x-axis. In that case, you must understand you can include the negative region also, because displacement is having the direction along with the magnitude. We are interested in the direction, whereas in distance time graph, we do not look into the direction. We will consider only the magnitude. In this acceleration time graph, the line like this shows there is no acceleration. The acceleration is 0. In this graph, there is some acceleration and this acceleration is constant. I hope you understood the graphs of motion. Thanks for watching the video. If you like it, please share with your friends. If you have any questions, please contact via email pjscracker@gmail.com.